Here we are in Nemo's room. Watch and observe him as he studies hard for the tax test tomorrow. He knows everything in math, and he's very good at it. But like any other person, he's still nervous. Wait, correction. He knows everything in math, but probability. He fell asleep in class the day the teacher taught it. And now he has to make it all up in one night and learn it all before the tax test. That stinks for him. I wouldn't fall asleep in class. I take pills to keep me awake all day and all that stuff. But who cares about my personal life? I'm just a mysterious, deep voice of a narrator coming out of nowhere. Let's get back to the story and see how he learns it.
Come on, come on, come on! Man, why does probability have to be so hard?
You mean, why did you have to fall asleep in class when the teacher taught probability? You wouldn't have this problem then, if you hadn't fallen asleep.
Narrator, stop interrupting me!
Sorry. Let's get back to the story.
Anyway, tax test tomorrow. I have to learn probability in one night and stay up so late. I'm gonna fail. I'm gonna fall asleep in the middle of the test because I didn't get any sleep. And I'm not gonna know probability either. Well, they did say to get some sleep before the tax test.
I think I'll just take a little nap.
I'm just gonna go to sleep. Whoa, where am I? This forest is so dark. And I'm just a floating head. How weird and random is that? Well, it's actually kind of cool. But anyway, hello? 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 Man, the only other person here is my echo. I'm alone.
Not true.
Huh?
You're not alone. There's lots of us here. And you're in the dream forest, the place where all people go when they dream.
Who said that?
I did.
Whoa, a talking tree.
What? You've never seen a talking tree before? Oh, that's right. You're from the waking world. Well, here in the dream forest, there's lots of talking trees. Is there anything I can help you with while you're here?
Well, I guess. Well, you're a tree. You're probably not that smart. You probably can't help me.
What? I'm so smart. I got top honors from all the colleges in the Dream Forest. What can I help you with?
Well, you see, there's this big test tomorrow, and I need to learn probability.
What? Probability? That's so easy. I'm so good at it. I can totally help you.
Thanks. So where do we start?
Well, first things first, you need to know what probability basically is.
What is it, Tree?
Well, probability is just the measure of how likely an event will occur. They're written as decimals or fractions from 0 to 1 and percents from 0% to 100%. The higher the probability's number, the more likely an event will happen.
That sounds pretty easy, Tree.
Wait until you get to theoretical probability.
What in the world is that?
Oh no, I've gotten too far ahead. Let's back it up a little. Here's some other things you need to know for probability. Listen carefully because these are important things to know. Okay, what's your name?
Nemo.
Okay, Nemo. Listen up.
Got it.
An event with a probability of 0 or 0% will never happen. Events with probabilities with 1 or 100% will definitely happen. 5/10 or 50% events have an equal chance of happening or not happening. And here are some terms you might want to know. Impossible means an event will never happen or a 0% chance. Unlikely, an event will most likely not happen. As likely as not is an equal chance of happening or not happening, so it's a 50% chance. Likely means an event will most likely happen, and certain means an event will for sure happen or a 100% chance. Got it?
Got it.
Good. Now, did you watch the weather this morning?
Yes.
And what it say for the chances of rain?
What does that have to do with anything?
Just do it.
Okay, the weatherman said that there was a 70% chance of rain tomorrow.
Good. Now let's find out the probability for that.
How?
First, let's remember that an event with a probability of 0% will never happen. An event with a probability of 1% through 49% is unlikely to happen. An event with 50% probability is as likely to happen as it is not. An event with a probability of 51% through 99% is likely to happen. And an event with 100% probability will definitely happen. What was the chance of rain tomorrow again?
70%.
Okay, that falls between 51% and 99%. So then that means it is likely that it's going to rain tomorrow.
Good. You're really catching on. Really?
Yeah, you're learning really fast.
Okay, so what's next?
We're going to move on to experimental probability.
What's that?
Well, first, you need to know about experiments. Experiments can help you estimate an event's probability. An outcome is the different results of an experiment that can occur. An experiment is an activity that could have many outcomes, like tossing a coin and see which side it lands on. If an experiment is repeated many times, you get an
experimental probability.
Good. It is the ratio of how many times an event occurs to how many times you did the experiment. Probability equals the number of times an event occurs to the total number of trials. Probability can be written as the variable p. Let's do a couple quick experiments to get a feel for experimental probability. We're going to spin a spinner with 4 sections. A couple spins later.
We're finished spinning the spinner. What are we going to do next, Tree?
I was thinking we were going to flip a coin.
Ooh, can I flip the coin?
Okay, you can flip the coin. You're so jumpy and fun. You remind me of myself when I was a young sapling.
A what?
A sapling, a young tree. Anyway, let's flip those coins.
You mean me?
Whatever. A couple flips later. Okay, Nemo, we finished with the experiments. Let's look at the results for the spinner. The spinner landed on red 6 times, on green 3 times, on blue 5 times, and on orange 6 times, adding up to a total of 20 spins. And for the coin toss, it landed on heads 6 times, and on tails 4 times, for a total of 10 tosses. Now, let's have some practice finding the experimental probability for these experiments. The spinner landed on red 6 times out of 20 total spins, so the probability, or p, for getting red on the spinner is 6/20. You must simplify it, so change it to 3/10. The quarter landed on tails 4 times out of 10 tosses, so the probability, or p, for getting tails on the quarter is 4/10. Simplify it to 2/5. Okay, Nemo, we finished with experimental probability. Ready to move on to theoretical probability?
Yeah, I am.
Okay, theoretical probability is used to determine the chance of an event happening without doing an experiment. If all the possible outcomes have an equal chance of happening, it is fair, but not all theoretical probability situations are fair.
Ooh, tree, a spinner. Can I spin it?
I'm sorry, Nemo, we're not going to spin it this time.
Man!
But watch. Notice how all the sections are the same size and area, so that means it is a fair event. Good job, Nemo. And there are 4 sections, so that means each section has a 25% chance of being landed on by the spinner. This can also be written as 1/4. Got it?
Ow, yeah, got it.
Nemo, why are you talking in a country accent?
I don't know.
You're creeping me out, Nemo. Stop. Okay. Thank you. Now let's move on. Now we're going to learn about sample spaces. A sample space is all the possible combinations and outcomes of an experiment. You can use tree diagrams, lists, and multiplication. Here's what a tree diagram might look like. This tree diagram shows all the possible outcomes of an experiment, which is tossing a coin. Good, Nemo. Notice how all the outcomes branch off of each other, like branches on a tree.
You mean like branches on you?
Why would you think that? Because you're a tree. Oh yeah, sometimes I forget that I'm a tree, till I remember I'm rooted to the ground. I can't go anywhere. Can't see the world. Can't have a life. Tree, don't get all emotional on me. Oh yeah, sorry, I wasn't getting emotional. Just getting emotional. Okay, I was. Here's some other ways to show sample spaces. You can also use a list to show sample spaces. Your first toss on a coin could be heads, and the second one could also be heads. And your first one could be heads, but your second one could be tails. Your first toss could be tails, but your second one could also be tails. Your first toss could be tails, and your second one could be heads. You can also multiply to show sample spaces. There are 4 groups of 2, so 4 times 2 equals 8 possible outcomes. Got it?
Yeah, I got it. Wow, I'm really getting the hang of this thing, aren't I, Tree?
Yep, you are. I'm proud of you. I'm a good teacher, aren't I?
Yeah, stop bragging about how good a teacher you are.
But wait, there's one more thing you need to learn.
What is it?
You need to know about independent and dependent events. An independent event is when one event's occurrence has no effect on the other event's chances of happening. Rolling dice is an independent event because rolling one number doesn't mean you can't roll another number.
Man, it gets easier and easier every time.
Nemo, I'm not done.
I'm still listening.
And now for dependent events. Dependent events when one event's occurrence affects the other event's chances of happening. 2 lunchboxes have apples in them, and 1 has chicken in it. If an apple is pulled out and not replaced, now there are only 2 lunchboxes left and a 50% chance of getting an apple, as before there was a 2/3 chance of getting an apple. Well, Nemo, it looks like you're done with probability.
What? That's all there is to know?
Pretty much, yes. You'll learn more in the future, but for now, you're good to pass the tax test.
Wow, thanks, Tree. You're a really great teacher.
I know. Now this is very important, Nemo. When you wake up, remember what I've taught you about probability for the tax test tomorrow. It's time for you to wake up and return to reality. Goodbye, Nemo. Now we return to Nemo's bedroom as he awakes from his strange math dream.
Whoa, I'm awake. That was some dream, but at least now I know how to do probability. But that dream was kind of just strange. I mean, I was a floating head and a talking tree taught me probability. Isn't that weird?
You said it. That dream was kind of weird.
Ah! The tree followed me into the real world!